My name is R. Crosby Lyles, and this is News from the Can. Basically, this is it right here. This is the 500 hectopascal level of the methane forecast for February 15th, 2022. And as you can see, it's 2,320 parts per billion. So that would be 2.3 parts per million of methane across the northern hemisphere, the upper portion of the northern hemisphere. So, and just to cut to the chase, I mean, there's this, but then here's Climate Reanalyzer. And right around the straits up here, right around between Alaska, where the finger of eastern Siberia is touching the hand of Alaska, where America and Russia are shaking hands, so to speak. This has been there's been a persistent blob of abnormally low temperatures, or what you would call, below baseline. And not really, well, I mean, you see it, what's the link? Methane necessarily reacts with oxygen, produces carbon dioxide and water. So, you start at the surface, you see a lot of methane coming up from Russia. That's, Russia/Siberia down here. Kind of in the middle, but of course, the big producers. You've got some in Brazil and a good bit, it looks like. Generally in the wintertime, your methane emissions will be up because it's this is from natural gas exploration and delivery, a lot of it. But of course, you got a lot of natural gas and methane coming from India and China, rice fields in India and China and so forth. So anyway, from whatever sources that they are, they're anthropogenic sources. And you can see that. So this is the surface level, but you can also see that there's a small amount sort of hanging out. Now bear in mind, this line at the top here is 1 point. That is the North Pole. So this area has a higher concentration of methane. Cold temperatures will have a tendency, I think, to keep it from reacting, keep it in its gaseous form. I think more sunlight, higher temperatures will generally cause the methane to react. And so ozone is produced from a photochemical reaction methane is a reaction body. So the presence of methane, which is a volatile organic compound, the principal volatile organic compound, causes a production of ozone. That ozone turns around and will react with methane at some point, depending on what the conditions are like. Methane is not very soluble in water. Methane will just sort of, it just does not get does not absorb, is not very soluble in water. Carbon dioxide, on the other hand, is very soluble in water. Okay, so here you have 850 hectopascals, about 1,200 feet up, roughly. And that's, pretty wicked. So, but it's just this amount. So 500 hectopascals, that's about 18,000 feet, I think, something like that, roughly. This is absurd. So it's just sort of like, and I mentioned in the last video, this keeps getting worse and worse. And it appears to be, if you were to use the surface as some sort of a point source analysis, it appears to be it's mostly from anthropogenic sources. But there does seem to be a higher concentration sort of drifting over the ice, as it were, and around the poles. 300 hectopascals, I'm not sure what that is, like 30,000-ish feet, something around there. 300 hectopascals, still pretty ugly, but when you get to 50 hectopascals, it's about 60-ish, 7,000 feet, somewhere in there. It diminishes quite a bit. And you can kind of see how the airflow up there. And you end up with a band of methane across the equator. So here's your carbon dioxide surface level. And notice that this is basically a northern hemisphere effect. 850 hectopascals, 1,200 feet, right? A little more prevalent. So because it's in the northern hemisphere, your heat trapping is going on. This is your polar amplification, which is a north pole sort of phenomenon at this point. 500 hectopascals, and there it is. So your level of methane at 500 hectopascals is a bit of a match there. Methane forecast, right? Carbon dioxide. Go up a little bit further, 300 hectopascals, about 30,000 feet roughly, which is 10 kilometers. You can see it breaking up. You can see that these shapes are from, the wind patterns in the stratosphere, or nearing the stratosphere. And then 50 hectopascals, same thing, right across the equator, but this band of CO2 is thicker. It's wider, covers more area. Well, that's a lot of, there's like a heavy concentration of CO2 building up over the Antarctic. Kind of more so than, you're talking about, well, here, on this, sometimes on my phone it says 600 parts per million, it says 1,000. Yeah, go figure. But yeah, this is, now at this level, this causes cooling because of where it is. You look at the lapse rate. That's according to Grind Up Baker, and he's quite right, I believe, that if you look at where the greenhouse gas is, you look at the lapse rate. So in the stratosphere, the higher you go, the more temperature you have. So I think that's a positive lapse rate. So you end up with actual global cooling at that point. And then below that, if the lapse rate is negative, then you end up with global warming. So this CO2 here at 500 hectopascals is probably going to have a warming effect, and it's mostly over the upper reaches above, well, it's really above the equator, but really thickens up above the 30th parallel. And so that's closer in, then it's going to produce your warming. Whereas the 50 hectopascals is going to... So this necessarily could cause changes in ocean currents and temperature. And then you look at Climate Reanalyzer and the sources. I've gone ad nauseum about this. Their sources are, global, the GFS and all that. So it's it's a legitimate source. It's a product of the University of Maine Climate Change Institute of the University of Maine. So and we've got some persistent abnormally cold or below baseline, and that's from 79 to 2000 base. So yeah, there it is. Sea surface temperatures. On the other hand, sea surface temperature anomaly is a little bit of a different story. But this is, this methane is necessarily going to launch, in my opinion, is necessarily going to launch water vapor into the stratosphere. That's what it looks like to me. I need to see what the other instruments are saying. I know that the moon lately has been looking somewhat, misty up there. That seems to be there's a lot of refraction in the atmosphere. So, yeah, that's nuts. And that's all I got. It's a quick update. I mean, this is, it appears to be coming from anthropogenic sources. 850 hectopascals. It appears to be coming from anthropogenic sources. Makes me wonder if this is what why the Russians want Ukraine so bad. Well, obviously it's why they need a warm water port. The whole deal with Ukraine, trying to, iron boot Ukraine. It's about maintaining a warm water port. I don't know, we'll see what happens. But, that's, I don't see the point source. I don't see any other than anthropogenic point sources, of course, over the ice, and then, I don't know. It only gets like this in the wintertime. Europe, I've done many videos on this already. And you got a lot of stuff leaking off of the Persian Gulf So that's not going to be good. We've had a lot of volcanic activity, and you see what those those temperature differentials look like. So that's sea surface temperature anomaly, and just for balance, here's sea surface, the actual sea surface temperature. You know. So again, with temperature differentials, the land has a lower heat capacity than the ocean, and so oceans get warm, they stay warm, the temperature drops over the landscape, and it causes airflow patterns to lock into position and just drop massive amounts of snow, rain, whatever. We've already seen that. So, but anyway, it's just really, this is just an update on this situation here at the 500 hectopascal level. It's kind of ridiculous. 2,320 parts per billion. Sort of like, red line. Again, if anybody sees anything different out there, leave a comment. Has any insights? Has any greater view or insight about what's going on? If we missed something, we're misinterpreting something, pipe up, because this could be this could be not a good harbinger. I'm looking at this and it's like, that's pretty ridiculous. At the 500 hectopascal level, you're going to have here. Let's take a look at that ozone. Ozone. Yeah. There you go. I've seen it a lot. I've seen it worse than this. I've seen some wicked, the past couple of years, I've seen some wicked ozone. Ozone also, all these gases are greenhouse gases. Your nitrogen dioxides and sulfur dioxides and ozone and methane, carbon dioxide, water vapor, they're all, greenhouse gases, but it just depends on where they are as to whether you get cooling or warming. Greenhouse gas higher up, water vapor higher up. If it's up high enough, it just creates an albedo blanket that can blot out the sun, and that's the thing. So it's in the geologic record where this whole channel started from. This was predicted by a couple of guys that they're not scientists. Art Bell and Whitley Strieber, they sat down to write a book, a fictional book, and then they saw this pattern from the geologic record that there are periods of global warming that are followed by glacial periods. It's a sharp turnaround. It's not a slow progression. It's rapid. And then you ask any climatologist and they will tell you that rapid changes in the atmosphere, that rapid changes in temperature must be caused by changes in the atmosphere. And in my mind, the only thing that can be is, it can be a lot of things, but good candidates for that are greenhouse gas in the stratosphere and massive amounts of water vapor in the upper, in the stratosphere. high in the stratosphere. Ice crystals, whatever. So anyway, it's in the geologic record, so it's just a matter of figuring out what the triggers are. And I think it's pretty obvious at this point that it has something to do with methane. So, I mean, you know, look, if you're going to have a clathrate bomb that would cause the Earth to, you know, to spin out of, you know, to heat beyond, you know, to just keep heating and heating and heating and turn it to Venus, it would have done it already. It would have happened already. Without any help. But it didn't do that. Not without a massive volcanic eruption. Acid rain is you know, that's what causes the root cause of all that mass heating. So, anyway, that's all I got. My name is R. Crosby Laws. This is just a quick check-in here. You know, you can see the shit's hitting the fan. You know, be prepared. Get a whistle. If you live above the 40th parallel, you know, if you live in China or, you know, across Europe and America, Canada, or wherever you're living, you know what I mean? If you live above the 40th parallel, it's a good time to have your shit together. You know, ham radio. They make these little ham radios. You can get them on Amazon. I don't sell any of that crap. You know, but it's, you know, to communicate or to get information, news, whatever. You know. You know, alternative forms of communication. You know, pay attention to the weather, and you know, it's good to have things in your vehicle. Apparently Teslas have something called camp mode. If you get stuck in traffic like some people were, and they just put their car in camp mode and they were fine. So they have, you know, the battery powered cars have functions in them that allow them to, you know, allow you to survive being stuck in your car for a long period of time. So yeah, just, you know, be able to get the snow off your roof, you know, all that stuff. Extra provisions, extra medication, you know. I mean, it's sort of like, you know, stock up, be ready during the winter time. And, you know, we just really don't even know how this, you know, how this thing's gonna go down. It could get weird. It could get funky. What am I looking at here? Oh, yeah. This is ozone. This is 300 hectopascals. Well, that's a really fascinating. How the air movement drives production of ozone here. Wow, yeah, there it is. And notice this is at 50 hectopascals. This is the stratosphere. See where all that ozone is. That's where that methane is going up. Methane necessarily produces, the presence of methane, volatile organic compounds in the atmosphere will produce ozone. Will allow, because the reaction body will allow the production of ozone. And so there it is. So you've got more ozone over in the, you know, in the northern hemisphere, and less over the equator. Hectopascal, where all the carbon dioxide is. So, yeah. And that's it. And you see this drop in temperature here. This has been persistent right here over the, like I said, right over the Straits, Alaska, eastern Siberia. We'll see. You can see what's going on. Central Siberia, and Harbin is like one of the coldest towns in China. You know what I mean? It's always cold as hell there. So yeah, it's looking like it's so yeah, figure it out. And that's it. My name is R. Crosby Lyles. Thanks for watching. Love you guys. Get your shit together. Seriously. If you live above the 40th parallel, extra provisions in your cars, I can't say it enough. Jug of water, a bucket to piss in, blankets, snacks, toilet paper. Carry some toilet paper with you. Have a lid on that bag. You don't want to have a lid on your bucket in case you got to take a dump. You know what I mean? Because there was a dude that was buried in snow like last year, year before that, for like 10 days, 2 weeks, something like that, buried in snow in his fucking car. You know what I'm saying? So it's just, be afraid. Just know what's out there and, be aware of it. And think about what you're doing. That's all. That's a shitty place to be. You know what I'm saying? So, if you got health issues, you really want to pay attention to that weather forecast. If you're going to be driving, even short trips and stuff like that. A good cop whistle, and stuff, a flare gun even, obviously want to be careful with that stuff, but, if you got a power generator, you want to make sure that thing is well ventilated and away from your house so you don't gas yourself with carbon monoxide, because this is the shit that happens when it turns cold and the power goes out. It's like we have to relearn these lessons all the time, and if you have it in the front of your mind and you have your shit together before the shit hits the fan and you're thinking about this stuff beforehand, then you're less likely to have, sad events unfold. And that's it. My name is R. Crosby Lyles. Thanks for watching. Take care. See you.